All right, so why is data visualization very important? As we all know, and remember when we talked about data is the new oil, and data now is everywhere, right? And that exponential increase of data has far outpaced our ability to understand that data. So a lot of employers have been struggling to find employees that have that skill set that can transform raw facts or data to useful information for decision making, where they can benefit from it, increase that profitability, the bottom line that we talked about. And as a result, a lot of universities have been trying to meet that demand, to equip students, to train students with those skill sets that employers have been looking for, right? So our university was one of the early ones that created the Master of Science in Business Analytics. Now we started the last fall, we started the minor in Business Analytics, and we're going to start the major in Business Analytics this coming fall. So those are actually the classes that are going to prepare students to help transform data to useful information for decision making. So there has been some new job titles that have appeared recently as a result of this boom in business analytics and data science and so on. And in this specific area, the most common title for employees in this area is data visualization specialist, data visualization engineer sometimes, Tableau programmer, just kind of to name a few. And again, they emphasize that storytelling and data translator, they all call them as well, because you have that data, you want it to translate it to something that the top executives or the lay person can understand, right? So those are some of the examples of the titles that you might be interested in when you graduate from this class is data visualization specialist, data visualization analyst, business intelligence specialist, because this is what we're learning this class is basically data visualization. I mean, it is business intelligence, right? Business intelligence is from the raw facts from data all the way where we get into reporting that data, visualizing that data. That's basically, and that's most of almost 70% to 75% of organizations that they claim that they are using business analytics, they actually stop at that point. They use business intelligence. They use Tableau or Power BI, and that's where they stop. But that 25% or 20%, that's where the machine learning, the prediction, the AI comes to play, right? And if you have taken the Python course that Dr. Hughes taught, and also if you are planning to do take some of the classes that we're going to offer, whether you are a minor or a major, we're going to provide and offer more advanced courses in the data science per se, right? There is I believe one course called data mining course that goes through a lot of those skills that you need. So you might have heard about Edwards Deming in your operations class. So Edwards Deming, he's the godfather of continuous improvement philosophy when it comes to production and operations, right? So he says, in God we trust. Whatever God tells us, we trust that 100%. All others, we must bring data. And that's where we come to play in this class. We need to show whatever our hypotheses are, whatever our support, we need to support that with data, right? So this is kind of the life cycle of business intelligence. We have raw facts. It can be numbers, it can be images, it can be names, it can be characters. By itself, it can be in a spreadsheet, but by itself, it doesn't do anything. We can't extract anything from it, right? We need to process that and transform it to information. And we do that. You know, this is going crazy, but you'll be bear up with it. Maybe I'll just close it, or hopefully it doesn't bother you guys. But So we need to transform that data into information by asking and answering those questions. What is the average? What is the total? What is the most common, right? What is the highest? What is the lowest, right? When we translate this into analytics, is what is the maximum? What is the minimum? What is the average? What is the count, right? So those are what is the sum? And those are the things that we use to transform data to useful information, right? To answer questions that ask what is the total, what is the average, and so on. Then when we have that information, then we can move on to the knowledge. Knowledge, we have two types of knowledge. We have explicit knowledge and we have tacit knowledge. So tacit knowledge comes from education, from experiences that you have done, right? It is accumulated and it is very hard to transfer because it is not tacit, that is already implicit, it is already within you, but you don't know you know it to tell other people that you know it until the need comes, and then it comes. That's where through education you get that tacit knowledge. So you combine that tacit knowledge, which you have learned through education system and through experience that you have done in that field, add it to the information that you have just got from the data. You combine all of that, then you can transform that into actions, into policies, where you can say, well, an example of the data is, let's say 23. 23, what is 23? When we see what is the average patient that we have received last night in the ER, that was the average is 23 years old. All right, so now that's answering what is the average, which is giving us the information. Now, in the knowledge is asking why. Why was the average age of patients who came to our ER last night was 23? Well, go investigate diagnostic analytics, go think about it, interview other people, talk to people, combine what you have learned and so on. It might turn out that maybe people had a party and somebody put something in their drinks, right? Just get it as an example. But you get the idea now how we can utilize all of this to transform that into action, right? So this is an example of how we transform data to useful information. Remember when we say we transform data to information by asking the questions is what is the average, what is the maximum, what is the minimum, or how many, right? So now we are asking how many sevens do we have in this graph? So if I ask you how many sevens in this graph, can you answer that question? You can, but there are two problems with it. First one is it's gonna take longer for you to go and spot sevens. The second problem is you might miss one. So in other words, you will have errors and it takes you longer to identify the seven and come up with the correct answer. So those are the two issues with this data. Now, if I highlight in blue the number 7, as you can see, it makes it much easier for you now to count how many sevens we have here, right? So if I bolded that 7, it makes it even easier to spot that 7. If I underline it, if I use context and I use underscore for it, right? Then it makes it much easier. If I use texture, it makes it easier for us to spot. So those are the things that we call them here: color, size, orientation, texture. We call them pre-attentive attributes. So what we mean here by pre-attentive attributes, those are the pre-attentive attributes. Our brain processes information within 250 milliseconds through those pre-attentive attributes. Through color, it identifies the color, identifies the size, the orientation, texture within 250 milliseconds before it starts focusing on any other thing. So that's very important to keep in mind. And that's why we use color kind of to get that attention really quick. Size, the texture, the orientation, and so on. So again, if we order those sevens, then it makes it even easier if we could put them all in one row. Makes it much easier and faster for us to count them. If we gray out the other information that way, our focus is 100% on the sevens. It makes it better for us. So now we have that information. Can we visualize it? Makes it even better for us. Now we can answer that question. Now we can see that 17 or 7 is repeated 17 times. Right? It is helpful to see this graph. However, we can make it even better. If we order this graph in a descending way, we can answer even more questions. So for example, in this graph, we can answer what is the most frequently what is the most frequent number? We can answer that question right away from this graph. What is the least frequent number in this data set? We can answer that. What are the top 3? What are the top bottom? What is the rank of 7 in this data set? So we can answer all of those questions, right? So that means we transform this data into information and useful information. One thing that we are going to get into one module where we talk about pie charts. Pie charts, they are the worst graph that you would have used in this class. So if you use it and I grade your work, I don't want to see any pie charts. And we will talk about why it is very important not to use pie charts, because those are some of the problems here. Is the labeling problem, because you can see here, I need to look at the size of the pie, and then I need to go see which group does it relate to, right? It takes me a while to go back and forth, and then also the colors. There are so many colors, especially if I have multiple groups. Which one is the blue? Is the dark blue or the light blue, right? Or the dark red? So it has a lot of issues with labeling problems, color problems, and also hard to compare. So now if I look at the green and the purple, which one is higher? Are they the same? Are they different? By how much? It doesn't give me that information, right? So that's why pie charts, we're going to stay away from it. Again, this is kind of to summarize, business intelligence is basically going through transforming that data to useful information by asking questions. What is, how many, how much, what are, and then that's where knowledge comes. Why is this happening? And then how do we, for example, if we are manufacturing, building widgets, right? How many products did we will produce last month, right? And then the question, why did we produce that much in comparison to last year, right? And then we can answer that question. Maybe we lost some employees, they left, maybe some of our machines are outdated, and so on, right? Now, what are the actions? So that's the most important thing, is the last step. We have all this fancy information, we have that, but what are the next steps that can help us improve that bottom line? All right, so now we are going to update that machine so we can produce better. That's one action, right? Again, that would help us increase our production. So that was in terms of why, what is data visualization and why it is important. So let's go briefly over the history of data visualization. So data visualization has started or has been used in the 2nd century by an Egyptian, which was in Egypt, and they used tabular format to present data. So that was the first time in the 2nd century. And then René Descartes introduced to us the 2-dimension coordinates that we have been using in college algebra, right? And Cartesian coordinate systems. And then William Playfair, Scottish engineer, introduced for us that linear, or what we call it, the linear arithmetic, which is the time series line graph, the bar chart, the pie chart, right? And then in the early 19th century, Charles Minard, he introduced for us or the map of Napoleon Russian campaign. That's very well known, and we will get into this later on. We will explain it in more detail, I believe, in one of the future modules. In the 20th century, Jacques Perkin, he introduced the science he called it semiology, which is the study of science. So in this semiology, he is the one of the first to present for us that pre-attentive attributes that we talked about earlier, right? So the pre-attentive attributes, which includes color, size, and texture, just to name a few, right? So he talked about those pre-attentive attributes in his publication. So Jean Taki, if you have used SPSS, you will definitely see Jean Taki test for robustness. So he introduced the exploratory data analysis. He also introduced the box plot and the histogram, the Pareto chart that we use in information systems. If you have done project management or system analysis and design, so Pareto chart is used, and the scatter plot. So Edward Tufte, he's one of the pioneers authors, and he was teaching in Yale. Who introduced or wrote about data visualization in the recent time. So he pioneered data visualization publications, and again after him. So this is one of the books that he is well known for, The Visual Display of Quantitative Information, published in 1983. William Cleveland, also, he is publisher. Or other research papers or books on data visualization came after him and introduced the Terralise. And then we have Stephen Few. So Dr. Few, he is a student of Tufte, and we will talk about him later on when we are talking about some of the best practices when we are creating graphs. So Dr. Few, he took a class actually with Dr. Tufte at Yale. And as a result, he went so deep in data visualization. He authored a lot of books, and he is considered one of the godfathers of data visualization in the current era. Again, some of those attributes, we can attribute the success of data visualization to Steve Jobs. He's the one who came up with Macintosh. So we were just talking about Mac or Apple computers, right? They are the first computer company to introduce the GUI or the graphical user interface. So before that, IBM used to have PCs or computers, right? And all they use is the keyboard. So they use the arrow to go from one application to the other. They use the arrow and the enter. But in that screen. Right? But now when Steve Jobs introduced the Apple computer, he introduced those icons, and he also introduced the mouse for the first time. And that's why now we have that graphical user interface, or we call it GUI, right? So for you, if you are a programmer, you might say, oh, I'm more of a GUI. So you can learn data mining, for example, using a GUI software like RapidMiner, where you go drag and drop, or SAS, or Orange that I teach in my classes, where you drag and drop some of the widgets and they do all the analysis for you, right? But if you are a script programmer, you are not going, right? You just like to write the code like Python or R, right? So those are things that we need to acknowledge. And again, the mouse and the graphical user interface, it's not Steve Jobs invented it, but he worked for Xerox and he actually improved it and brought it from Xerox. So those are some of the kind of historical, the history of data visualization and how we are here today. So that was all that I wanted to cover with you today, and we will continue on Thursday. And so I will open it for questions, and if you have any questions for me about the course or yes, that's a good question. So the quiz also it's gonna be due either on a Saturday or Sunday, as it is mentioned, and you're gonna do it by yourself. Yeah. What did the quiz look like? Question mark. That's a very good question. So for example, today we went through the history of data visualization. So I might ask you, for example, Tuft, Dr. Tuft, what contribution, and then it's going to be in multiple choice, right? What is the name of the book he published, or is he a contemporary pioneer, or is he one of the earliest, questions like that. The way that I set it up right now is you can use your notes. You can use your notes, but I would suggest that you go through the lecture, go through the readings. That way you don't miss anything. So take notes, right? And that's why I didn't put too much weight on the quizzes. It's only 10%, but I want you to read. So that's why 10% just kind of to help you read, because without reading, you might not capture everything that we might cover in the class. There might be something in the reading that I might skip to or so. What else? What other questions do you have for me? I don't know what happened to the people from Brownsville. I hope they are here. I don't see them, but I hope they are set up there in Brownsville. You see me, but I don't see them. Anything else? Any questions? All right, so hopefully by next class they will fix the projector. All right, so if we don't have anything, then we can call it a night. And all right, have a good night, everyone.